So far, we've been investigating rational numbers. We've looked at fractions and decimals. We briefly touched upon radical is the right word, but square roots. We touched upon it briefly. We'll look at square roots a little more in depth in a couple more lessons. But for now, I want to focus on the heart and essence of rational numbers, which is ratios. Because if you look at the word rational, the first 5 letters spell ratio, which means all rational numbers can be written as a ratio. But what are ratios? Well, I'm going to define that for you right now. Ratios are, now remember this definition. Ratios are any time you compare 2 or more numbers. So you have 2 or more numbers, you're comparing them, you've got yourself a ratio. And there's 3 ways you can express those numbers as a ratio. I want you to learn all 3 of them. That's the first thing I'm going to teach you today. I'm going to teach you 2 more things. So the first thing is, how do you express ratios? Using 3 different ways. The second thing is, how do you make equivalent ratios? That's the second. So the first thing is, how do you express them? Second thing is, how do you make equivalent ratios? And the third thing I'm going to teach you today is life uses of ratios. Because you know what? A lot of things you learn in math, you'll never need to use ever again. I understand that. However, ratios are something that most people will use a lot. So it's important to learn this stuff. Very important to learn it. And I'll show you examples of where that applies. So ratios, how do you express them? That's number 1. First of all, you look at what you're comparing. We have squares here and we have hearts. Okay. So the second thing is, you have to put those numbers in order. You have to count these and you have to count those. You have to put those numbers in order. So look what we have. Squares first. So how many squares do we have? We have, let's see, 3 squares. So I'll write 3 along with squares. Tell me what that 3 means. I'm going to write the word 2, just like that says. And then I'm going to count the number of hearts, which is 2 hearts. 2H. That's method number 1 of expressing a ratio. You have your 2 numbers. Now look, if you flip those numbers around and you put the 2 first, 2 hearts, and then 3 squares go second, is wrong. That's right. You'll get the wrong answer. Order matters. So this comes first, and this comes second. The second way of expressing that ratio is to write it with dots in between the numbers. So we have 3 squares like that. We're going to put dots and then 2 hearts. Pretty simple. Here's number 1. Here's number 2. The last way is to stack them like a fraction. So we have 3 squares over 2 hearts. And I say like a fraction because it's not a fraction. Why isn't it not a fraction? It looks like a fraction. Here's the difference. Fractions, the denominator of a fraction, represents everything that you see in the picture. It represents the whole. Ratios, it doesn't. We don't have 2 whole things here. We have, count them, we have all these here. In ratios, we don't care about what the denominator representing. We don't want it to represent the whole. We want it to represent what it's asking us to represent. It's a comparison. That's the difference. Now we're going to move on. Now, after this, I'm not going to be using all 3 examples for every question. I'll rotate them because, number 1, we're limited on time. And number 2, I think you understand what's going on here. So I'll just kind of pick one at a time. So here we have red and green, and it doesn't ask us specifically what shape. So I'll just count all the red things. We have 4 red things. So I'll write 4R. And how many green things do we have? We have 2, 3 green things. Green things. Sounds like something that fell in toxic waste. And I'll put the dots in between here. That's good. Write the ratio of squares to triangles to hearts. Oh, we have 3 things. Oh my God, we got 3. Okay, so we have squares first. We have 3 squares. And I'll put dots again because it takes up less space vertically. The triangles, I have 2 triangles, 2T. And then hearts are last. We have 2 hearts. We're done. This is how you do this. That's how you express it. Now this one says hearts to squares. So we have 2 hearts, 2H. I'll use the word 2 here. To how many squares? 3. 3 squares. Now I'll use a fraction representation. Green things to stars. So I have 3 green things. I'll write 3 green. And how many stars? I have 3 stars. And actually some of those stars are green, so they're going to fit in the top group. But if I count all the stars by themselves, I have 3 green stars. 3 stars, then I'll put all of them here on the bottom and I'll put the green things on the top. So I'll keep it like separate. Ratio of stars to yellow stars. So how many stars? Now it doesn't say what colors, it just says stars. There's three. 3 stars. And yellow stars, I have 1 yellow star. So I'll put 1 yellow star. Now the second thing I'm teaching you is equivalency, and it's no different than fraction equivalency. You're going to multiply or divide both numbers by the same number, and then that answer will be an equivalent answer. So we have 2 to 5, and I want to make something equivalent to this. I can times each of them by 2, and I'll get 4 to 10. Say it properly, 4 to 10, and these are equivalent. I can times both by 3, and I'll get 6 and 15. And I'll put an equal sign because they're all equivalent to each other. And I can times, and you get the idea, I can times by anything, and it'll make an equivalent ratio. Write a ratio here for the last one. That is equivalent to, now look, we have 3 numbers again. So what can we do here? I can double all these. I can times them by 2, and that'll make 6. And then double this, you get 42. And double this, you get 12. And that would be equivalent. There, put an equal sign. They're equal. Now we have to put them in lowest terms. Now remember lowest terms, what does it mean again? That's right, you have to divide them until they don't divide anymore. And of course you divide by the same number. So what goes into 14 and 24? That's right, 2 goes into both of them. So I can divide them both by 2, but don't write it this way. Don't do this. When you're dividing, I want you to do it this way. Like this, divide by 2. Looks like a fraction. Divide that by 2. That'll make 7. And that'll make 12. And there is no one number that goes into both 7 and 12. Yeah, I understand. 1 goes into both, but 1 doesn't change those numbers. Now, yeah, 2 goes into 12, but it doesn't go into 7. So we're done with this. Moving on to this next one. What goes into 6, 27, and 15? Because we do have to do lowest terms. So we have to divide. I'll put my division symbols. By the same number. Yes, 2 goes into 6, but does 2 go into 27? No, it doesn't. 3 goes into 6, 3 goes into 27, and yes, 3 goes into 15. If you divide them, you're going to get 2. You're going to get, what's this, 9? And you're going to get 5 here. And these won't shrink anymore. There's nothing that'll divide into all of them. Now, let me touch on this. Are you allowed to do this? Are you allowed to divide this by 2 and divide this by 3 and divide this by, let's say, 5? Do it like this. Are you allowed to do that? No way, because you have to divide by the same number. So don't do this. Let's get rid of it. Now, the last thing I'm going to teach you is where this applies in real life. I love to cook. I do. But here's the problem with recipes. Yeah, I know a good chef isn't supposed to use a recipe, but sometimes when you're learning how to make something for the first time, it's good to look at a recipe. Now here's a recipe for rice. The problem with recipes. The problem with recipes is if you look at the bottom, it says feeds 2 to 3 servings, or makes 2 to 3 servings, and that essentially means it makes enough food for 2 to 3 people. But what if you have a lot of guests coming over? What if you got to feed a lot of people? Well, that means you got to change the recipe now to feed them. So how do we do this? Write the original ratio. Well, let's read the question first. To make enough rice to feed 6 people. So we have 6 people. A recipe a recipe asks you to combine 2 teaspoons of salt, 3 teaspoons of butter, and all that other stuff you see. But here's the problem. What if you had to feed 12 people instead of 6? We got a problem here, but ratios can help fix it. Write the original ratio of ingredients that will feed 6 people. Here's step 1. You write the original ratio. The original one says 2 salts, 2 S, 3 butter, so write 3B, 2 rice, and 3 cups of water. 3 water. And that's for 6 people. So I'll write that on the side so I remember. But I want to make for 12 people. Let me ask you this. What did we do to the numbers to change them from 6 to 12? Yeah, right. We did add 6, but remember, you're not allowed to add or subtract to these numbers. You can only multiply or divide them. Right. We're multiplying by 2. We're timesing this by 2. So we have to times this by 2, times that by 2, times that by 2, and this one here to make an equivalent ratio. That'll make us 4 salts, 6 butters, 4 rice, and 6 waters. and put those dots in. Now, why is this important? Why couldn't we just kind of increase everything by a little bit and hope for the best that the rice works out? Because the problem is the rice then will either be too salty or a little bit more watery, or it just won't be as nice and it won't taste the same. But if you adjust all these ingredients accordingly, you've got yourself an equivalent ratio, and that means you've got a food that tastes equivalently the same. You've all seen these bags of fertilizers, but did you know that these numbers represent a ratio? They don't have the dots in between them. They just put a little line for a shortcut. But these numbers represent the ingredients that are included in this bag of fertilizer, which is nitrogen to phosphorus to potassium. This is 26 parts of nitrogen, which is important for making plants green. Very good for your lawn. To 2 parts of phosphorus, so not as much phosphorus. Okay, only 2 parts. Or 2 pounds, if you want to look at it in pounds. There's 26 pounds for every 2 pounds of phosphorus, for every 11 pounds of potassium that's included in this bag. Phosphorus is good for making flowers bloom. And potassium is good for like water balance and that sort of thing. But look at this middle number here, phosphorus. Not very much in this ratio here. But when you look at something like Miracle-Gro, because you need phosphorus to make flowers bloom, you've got 52 parts of it for only 10 parts of nitrogen. You see how the ratios change depending on what you need the stuff for? So that's another practical use of fertilizer. Here's another practical use. This problem here, this word problem. Let's make it a little bit bigger. We have now an instruction manual that says apply 2 pounds of fertilizer for 1,000 square feet. So we have a ratio here. We have to recognize that's a comparison. 2 pounds to 1,000 square feet. Does it say the word 2? It doesn't. But we know it's a ratio because it's comparing those two numbers. So I know it's 2. 2 pounds to 1,000 square feet. It's a comparison. But I have a problem because my lawn is 3,000 square feet. So I'm going to need a different amount of fertilizer. If I only use 2 pounds on my lawn, it's not going to be making much of an impact on my lawn. It's not enough. My lawn needs more than that because it's bigger. So I need more fertilizer. But how much more? If I use too much, my lawn will burn. If I don't use enough, it just won't be very green. Use it in the right balance and you've got yourself a great looking lawn. What did we do here to the 1,000 to turn it to 3,000? Right. We multiplied by something. By 3. So what do you think we do to the 2? Exactly. And that's going to make 6 pounds. And that's going to make a great lawn.